So this is almost the exact same thing as what's in your project, just the numbers have been changed, so you can repeat these steps to hopefully get this question right on your project. So we have these spiders. The spiders are symmetrical, and then I think they said they're spherical too. It says symmetrical. I think that we're just assuming that they're a sphere because these are equations for the surface area and the volume of a sphere. Okay, so the goal is to eventually calculate whether these spiders that are incredibly large, whether they could actually exist in real life and absorb the amount of oxygen that they would need to survive. So it breaks it up into parts for us. We're given different units, right? One unit is this is feet across, square inches. I don't know. This is all in English units. Oh no, here it's 28 milliliters of oxygen per second per cubic centimeter. So this one's cubic centimeters. This one's square inches. We got some different units going on. Okay, so since one of the rates we were given is in inches, we'll want to convert this spider's measurement to metric units. So our first goal is to convert 24.5 milliliters per square inch. Here, I'm going to write that out. That's 24.5 milliliters, and then they say per square inch. So that means it's for 1 square inch. So that's how you'd write that with units as a fraction. We want to convert it. We want to write its equivalent to milliliters per square centimeters. So we want milliliters per square centimeters. So we need to know the number that goes in this blank up here. In order to make that happen, we've got to cancel out square inches in the bottom to get square centimeters in the bottom. So we need a converting factor. And one thing we can use is that 1 inch is equal to, I think, 2.54 centimeters. Now that's a linear unit, right? That's just 1 inch equals, it's one dimensional, I should say. So if we want to make it two-dimensional, like inches squared, we need to square both sides of this equality. So 1 inch squared, 1 squared is just 1 still. So 1 square inch is equal to 2.54 squared centimeters. That's 6.4516. 6.4516 centimeters squared. And that's what we need. We're going to take the original units of 24.5 milliliters per square inch, and we're going to multiply by this conversion factor. 1 inch is the same thing as 6.4516 square centimeters. So I'm going to multiply by 1 square inch over 6.4516 square centimeters. That way we get the desired units in the denominator, right? Because just like with fractions, these can cross cancel when you're multiplying fractions. Those units are gone. Leaves us with what we're looking for units. 24.5 milliliters per 6.4516 centimeters squared. But we want to simplify a little bit more, because usually we don't express it in terms of anything other than 1 square centimeter in the denominator. So take the top number, divide by the bottom number. That's 3 points here, and you don't have to carry out a huge amount of decimals. It's where did it go? Come on, come back. Make that smaller. Forget it. There we go. That's what I want. Okay, so that's my answer. 1.1 converted to 24.5. I don't know where this is supposed to go. I converted 24.5 milliliters per square inch to milliliters per square centimeters. Okay, question 2 says calculate the surface area and volume of the spider in centimeters, using centimeters. So the surface area is found by plugging in the radius into this formula. Now my spider is, we're going to assume it makes a sphere. So if it's 150 feet all the way across, then R equals 75 feet. right? R equals 75 feet because it's only the radius is only halfway across. But that's in feet. We're supposed to calculate the surface area and volume using centimeters. So I actually don't know off the top of my head how many centimeters are in a foot, so I'm going to convert it by saying there's 75 feet and there's 12 inches per foot. That's 900 inches. And then I need to convert inches to centimeters. So 900, using my conversion factor over here, 1 inch gives me 2.54 centimeters. 900 inches gives me 2,286 centimeters. Okay, so that's what I've got to plug in for my radius when I'm calculating the surface area and the volume. So this is 4 times pi times 2,286 squared. So with my calculator, I'll do the exponent first. I'll multiply it by itself, and then times 3.1416 is an approximation of pi, and then times 4. So looks like we got 65,669,000. And then make sure to watch your units on this. That's centimeters squared. Okay. 65,669,442 square centimeters. Because surface area is like measuring two-dimensional area, left, right, up, and down. If you were to take a box and you were to take its side panels off and lay them down flat on the ground and ignore the thickness, you're talking about 2 dimensions. So that's why it's centimeters squared. And for volume, we're going to do something similar. It's 4/3 pi, our radius in terms of centimeters cubed this time. So 2286 times 2286 times 2286, and then times 3.1416 times 4, divide 3. So for the volume, we've got 50,040,000 50,440,115,455 and 5 hundredths of centimeters cubed, because it's volume, it's 3 dimensions, so we cube it. All right, obviously a huge spider, so we're talking about in centimeters, could be a huge number. Okay, we got the surface area and volume. So using the provided information in the second paragraph, could mine is 150. I forgot to change that one. Could my 150-foot long spider even exist? Why or why not? Let's see what we got. What does it need? My spider needs 28 milliliters of oxygen per second per cubic centimeter of volume. And their spider can absorb. So my particular spider needs 28 milliliters of oxygen per second per cubic centimeter. And then it's saying it can absorb it at 24.5 milliliters per square inch, which is 3.7975 milliliters per square centimeter. So for every square centimeter, we can absorb 3.8 milliliters. Right? We have every square centimeter of surface area on the spider. So we have this many square centimeters of surface area. I need to know how many milliliters per second the spider is going to be able to absorb. So I'm going to take my answer for the surface area, the 65,669,442 and 85 hundredths square centimeters. Okay, so we're going to take our surface area. That's centimeters squared. I'm going to multiply it. Oh, we can't cancel that out. I'm going to multiply it by the absorption rate. My spider can absorb oxygen rate of 24.5 milliliters per square inch of surface area. 24.5, but we converted that, sorry. That's 24.5 milliliters per square inch, which is 3.7975 milliliters per square centimeter. So I'm going to multiply it by my answer in part 1, 3.7975 milliliters per square centimeter. Okay, and that way, if instead of, we could have divided, I think you probably could have reverse engineered that too. Could have got it right if you divided. I just have to think about it for a while, but I'm multiplying instead of dividing. That way, these units can cross cancel, because cross cancellation only happens when you're multiplying two numbers, right? And by multiplying this, everything's in terms of how much we get per second. So 65,669,442.85 times 3.7975. So we got 249,379,709. And that's milliliters per second, right? Because, and just to recap, this is how much surface area we have. This is how many milliliters we get per second per squared centimeter. So it means we get this much per second. And then the volume of the spider, so the spider needs 28 milliliters of oxygen per second per cubic centimeter of volume. So that's its need. It needs 28 milliliters of oxygen per second per cubic centimeter of volume. So we have this much for its volume. And I'll label it a little bit. This is how much it can absorb. So that part we did up here is how much the spider can absorb. And then we want to compare it to how much it needs. How much oxygen the spider needs. This is how much volume we have. And for my spider, its needs were 28 milliliters of oxygen per second per cubic centimeter of volume. So 28 milliliters of oxygen. So we're going to 28 milliliters of oxygen per cubic centimeter. So multiply again by 28 milliliters per, and that's already it's in the right units, per cubic centimeters of volume. So this is centimeters cubed down here. Again, we're multiplying. That way we can see these units cross cancel and leave us with just one unit in common to compare them. So if we multiply those two, 50 billion, 40 million, 115,000, 455.05. Okay, so over a trillion when I work that out with a calculator. So this is the surface area. That's how much oxygen this creature can take in, right? So this is how much milliliters can absorb per second of this theoretical creature. It's in the millions. According to its volume, it needs 1,401,123,000,000, a huge amount of milliliters per second because of its large volume. So the surface area isn't enough to sustain the body of this creature. So could my creature survive? No, because the needs, this part that we calculated down here, the volume is too big because it demands too many milliliters per second when compared to the amount we can provide for surface area. So this thing could never exist because it's so far off from providing enough, what was it? Yeah, it was so far away from providing enough milliliters of oxygen per second.